All right, today's lesson is going to start with a warm-up. Let's go ahead and see if we can factor completely 98x squared minus 200. All right, as we continue, hopefully you remembered that you want to try to factor out any number value before you start looking for any difference of squares or other factors. So is there a number that can be factored out of both of these terms? They are both even, so at the minimum, they can both be divisible by 2. So 98 divided by 2, that gives us 49x squared. Minus 200 divided by 2 is 100. Well, now we should be looking and saying, hey, that is definitely difference of squares. I got a square, a square, and a square. And a subtraction sign in the middle. Difference of 2 squares. All right, so on the left side, we have 7x times 7x. That gives us 49x squared. On the right side, we have 10 times 10. That gives us 100. And so our solution for just the binomial, 49x squared minus 100, will be 7x minus 10, 7x plus 10. And remember that we want to drop that 2 down because that is part of our solution as well. That is factored completely. Today our focus is going to be on factoring by grouping and factoring trinomials. So factoring by grouping, a couple of things for you to write down. Make sure your polynomial is written in standard form. In other words, largest exponent on the left to smallest on the right. Now this isn't required, it just tends to make things easier. And if we can get easier, we want to use it. Group the first 2 terms in parentheses, group the second 2 terms in parentheses. Factor both groups individually. Pair together the values in front of each parentheses as one binomial. Make sure that the binomials in parentheses are identical. If they're not identical, the polynomial is not able to be factored. So, yes, I realize a lot of notes don't quite make sense until you've done it. So let's do it. So our first step was to make sure it's in standard form. It is in standard form. Then we pair the first 2 terms in parentheses. We pair the second 2 terms in parentheses. Now, I always like to have an addition sign between the 2, which means if this had been a minus 12, I would have paired the subtraction sign with the 12 using the additive inverse rule, and then written in a plus sign between the 2 parentheses. But since this is a plus 12, we don't have to worry about that quite yet. We'll see it as we move forward. So our next step is to factor each parentheses individually. So looking at just our left parentheses, we can see, hey, I have a factor of 2, and I have at least x squared in both terms. So if I divide 8 by 2, I'm left with 4. If I divide x cubed by x squared, I'm left with x. If I divide 2, I'm left with 1. X squared and x squared will cancel each other out. So that binomial simplifies to 2x squared times 4x plus 1. Now we move over to the other side. 12x plus 3, our common factor is going to be positive 3. If I divide 12x by 3, I get 4x. If I divide 3 by 3, we end up with 1. Now notice the value inside the parentheses is the same, so this is factorable. And I'm going to take the remaining values in front of the parentheses, and I'm going to pair them together with whatever operation sign is here. Come on. So we have a 2x squared plus 3. And I will keep one of the values in the parentheses because it's a duplicate of itself. So 4x plus 1. That's our solution. Now, Can we check it to make sure we did everything right? Sure. 2x squared plus 3 times 4x plus 1. And we already know that when we have two binomials, we FOIL to multiply. So we're going to multiply. 2x squared times 4x is 8x cubed. That's a good sign, right? We're already seeing one value that we want to see. 2x squared times 1, so plus 2x squared. Again, that's a good sign. That's something we want to see. 3 times 4 is 12x. 3 times 1 is 3. So when we FOIL, we end up with the same solution we started with, which means when we factored, we did everything correct. That is our final answer. Let's try another one. So we're already in standard form. So I want to put parentheses around my first term, parentheses around my second term, and factor. My common factor for the first set of parentheses is x squared. So x squared comes out front. That leaves 1x minus 3. Plus my common factor for my second set of parentheses, it looks like it's a y. So xy divided by y leaves with x. 3y divided by y leaves me with 3. Again, I see that my parentheses terms are identical. So I can keep one. And this term, or this expression is factorable. And then I'm going to pair together what is sitting in front of the parentheses. X squared plus y. So x squared plus y times x minus 3 should give us x cubed minus 3x squared plus xy minus 3y. All right, now, why don't you go ahead and try one? Now, oh wait, no, this one's got the negative. Let me show you what I do with the negative. Again, I put it in parentheses. I go ahead and put the negative or the subtraction sign in parentheses. And so now what I'm doing is I am adding negative 6x. I haven't changed the problem at all. That's no different than saying 4 minus 3 is the same thing as saying 4 plus negative 3. Same answer, same problem. Just a different way of expressing it. So I'm going to do the same thing. Instead of saying minus 6x, I'm going to say plus negative 6x. And now we factor. Our common term is 2x squared. And so that will leave me with a 2x minus the x squareds will cancel out. 6 divided by 2 is 3. All right, let's come over to the other side. Now, one thing to pay attention here. Notice I have a negative 6 here. In order for this to be factorable, my two parentheses have to end up with the same value in it, which means I need to have a positive 2x as my first term in the parentheses. The only way to get a positive 2x if I have a negative 6x is to factor out a negative value. So I'm going to start there. I'm factoring out a negative. And what can I divide 6x by to get 2x? That would be 3. So if I factor out a negative 3, negative 6 divided by negative 3 gives me 2 with the x. 9 divided by negative 3 gives me a negative 3. Notice that both of my parentheses are the same. So our final solution, 2x squared minus 3 times 2x minus 3. All right, let's play a game. Chances are pretty good that you've played this game at some point in elementary school. What are two numbers that add up to 15 but multiply together to get 56? And so we could start with 56 and find the prime factors. 56 divided by 1 is 56. 56 divided by 2, well, that's going to give us 28. 56 divided by 3, no, that's not going to work. 56 divided by 4 That's 14. And then you'll notice that I'm continuing to move on because 1 and 56 is 57. That's not 15. 2 and 28 is 30. That's not 15. 4 and 14, getting closer. That's 18, but still not 15. 5 doesn't go into 56 evenly. 6 doesn't go into 56 evenly. 7 and 8 do. And then we notice 7 plus 8 is 15. So the two numbers we're looking for are 7 and 8. What are two numbers that add up to negative 10 but multiply together to get negative, or try to get 21? Well, if they're going to multiply together to get a positive number but add up to get a negative number, they're going to have to be negative values. So negative 1 and negative 21. No, that doesn't add to negative 10. Negative 2, no. Negative 3 and negative 7. Well, sure, if we add negative 3 to negative 7, we get negative 10. So those are the two values we're looking for. What are two numbers that add up to negative 1 but multiply to negative 20? Well, if they multiply to negative 20, that means we're going to have to be dealing with a negative and a positive number. So negative 1 and positive 20, that's 19. Negative 2 and positive 10, that's negative 8. Sorry, that is 8. 3 doesn't go in evenly. How about negative 4 and positive 5? That's positive 1. Well, if that's positive 1, is it any chance that maybe that's the series of numbers we need, just in the other order? Negative 5 and positive 4. Well, now that will give me negative 1. So negative 5 and positive 4 are the two values we're looking for. This game comes into play as we start getting into factoring trinomials. When we are factoring trinomials, we're going to play the X games, which is essentially the same concept. And what's going to end up happening is we are going to take our middle term and write it here. We're going to take our last term and we're going to write it here. Now, this is only going to work this way when our leading term is 1. We'll have a different process for when our leading term is not 1. But right now, let's take baby steps. When our leading term is 1, we're going to play the X games. We want two numbers that multiply together to get 24, but add up to give 14. All right, let's think. Looks to me like our factors could be 1 and 24, but that's not it. 2 and 12. Wait, 2 and 12, that adds up to 24. So we write down the 2 and we write down the 12, and guess what our factors are? X plus 2 and X plus 12. Well, that seemed too easy to be true. Let's check it just to see. X times X is X squared. X times 12, well, that's 12X. 2 times X, that's 2X. And 2 times 12, that would be 24. So 12X and 2X is 14X plus 24 plus X squared. Wait a minute. That is the same thing we started with. So X plus 2, X plus 12. That childhood game that we have been playing for so long is now going to make factoring super easy. Let's try another one. We're looking for values that add up to negative 2, multiply together to give us negative 24. If it multiplies together to give us negative 24, we're going to be multiplying a negative times a positive. So we have 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. Well, 4 and 6, if one was negative and one was positive, at least gives us a 2. So when we're looking for a negative solution here, we know we're looking for the difference now between these two numbers because that's how we're going to get a negative there. So how do I end up with a negative if I'm using the terms 4 and 6? Well, Well, the 6 would have to be negative in order for me to have a negative solution. So negative 6 and positive 4. So our factors, x minus 6, x plus 4. Now again, you're welcome to check it, but I'm going to go ahead and tell you this is going to work every day of the week. X squared plus 16x plus 64. So our x games, we want numbers that add up to get 16 and multiply together to get 64. Hopefully this one's staring you right in the head, especially since 64 is a perfect square. So 8 and 8 makes logical sense. 8 and 8 does add up to 16, so x plus 8, x plus 8. Now we can also write this as x plus 8 squared because we have the same solution. All right, now I told you it's a little bit different when we have a leading coefficient that's not 1. But wait, before we jump into trying to make this more complicated than it is, let's notice every one of my terms is divisible by 2. So before we get into factoring the trinomial, let's factor out a common GCF. 2x squared divided by 2 leaves me with x squared. Negative 4 divided by 2 leaves me with negative 2x. 2 divided by 2 leaves me with 1. Well, now we have a simplified trinomial. Let's see if we can clean up that simplified trinomial by factoring. We want two numbers to add negative 2, but they multiply to give us 1. If they're going to add to a negative term, that's going to have to be negative values. And both of them will have to be negative numbers if we're going to end up with multiplying to a positive 1 solution. So the only number I can think of is negative 1 and negative 1. Negative 1 plus negative 1 is in fact negative 2. So we have x minus 1, x minus 1, and again we bring the 2 down. Now notice I have an x minus 1 and x minus 1. We could clean that up so we could finally say 2 times x minus 1 squared.